Welcome. Let's take a look at another group of students' exam scores. And this time it says construct a grouped frequency distribution of the data using an initial class boundary of 49.5, an ending class boundary of 99.5, and 5 classes of equal width. So in this case, we're given the boundaries, and that means to complete our table, we'll need to find the width ourselves using this formula. So we're going to start with our substituting ending boundary 99.5 minus the initial boundary. They'd like us to use 49.5, and we'll divide that by the number of classes that we're asked to create, and they said 5 classes. All right, so if you do your numerator there, that will be a difference of 50, and then I'll divide that by 5, so we get a class width of 10. So in our table, the lower boundary here for the first class, so our initial boundary is going to be 49.5. And then the width of the classes tells you the distance from the start of one class to the start of the next class. So if we add the width, we'll see that the next class starts at 59.5. And then I'm going to continue there, just going down and adding that 10. So adding the class width all the way down. So those are the lower boundaries of each class. And then for the upper boundaries, all we need to remember is boundaries touch. So where one class ends, the next one begins regarding its boundaries. So that lower limit for 59.5 is where the upper limit would be for the previous class. So for boundaries, those two numbers are the same. And then we can continue going down again by just adding the width. So we don't have to think so hard, just add the width. So boundaries always end in a 0.5 here, but our data are whole numbers, so it's usually easier, I think, to write the limits instead of the boundaries. So the limits are the whole numbers that are inside of these boundaries. So all the whole numbers between these values. So after 49.5 on a number line, the whole number next would be 50. And we have to say inside the boundaries. So right before you get to 59.5, that would be 59 as a whole number. So 50 to 59 are whole numbers between those boundaries. And then once you get started, you can just go down that page again by adding the class width. So the next grouping would start at 60 and then 70, 80, 90. And equivalently, you can do that for the upper limits. So 59, add 10, 69, 79, 89, 99. All right, so with limits, if the first class ended an upper limit of 59, then the next class would begin at the next whole number, 60. So these values are consecutive because we don't want any overlapping. We call these sets mutually exclusive. So values here cannot be here. So that's why we don't have these values touching one another like we did for the boundaries. All right, that's our setup. And then we can start counting students. So basically students in the 50s, 1, 2, 3, 4, 5, 6, 7 of those. And if we count our 60s, you'll see 8. And then 70s, it looks like 6. 80s, just 3. And then 90s, just 1 student. All right. So just as a quick check, we could add those frequencies together. And that is going to be, I believe, 25, but I'll just type it in here and make sure. Yes, we have 25 students in the class, so 25 grades. And we could build a histogram based on frequency. But here I'd like to actually do a relative frequency histogram. So rather than seeing whole numbers, we'll convert these to relative frequencies and work in either fraction, decimal, or percent. So let me just write the formula here we learned for relative frequency. So relative frequency means the frequency, the count, but we want to know out of how many data values. So our number of data values there, 25. So the students that got between 50 and 59, there were 7 of them, and it was 7 students out of 25 students. So in the next group, it was 8 students out of 25, and then 6 out of 25, 3 out of 25, and 1 out of 25. So proportions or relative frequencies, we can certainly do fractions, or I'm going to change these to decimals. So I'll do the first one there. 7 over 25 would be 0.28. 8 over 25, 0.32. And I'm just going to write in the rest here. You can certainly check, but that will be 0.24, 0.12, and 0.04. So when I create the graph, I am going to use the decimals, but it can never hurt here to practice percents. So 28% in the 50s, 32% of the group scored in the 60s, 24% scored in the 70s, 12% scored in the 80s, and then just one student, the equivalent of 4% in the 90s. So if we add those relative frequencies, we should get all 25 out of 25 students. So adding those fractions, we've got that common denominator. Adding the decimals, we'll get 1. And adding percents, 100%. So we know we've got all the data in the table. And then we'll change this into our visual display called a histogram. All right, so it asks for relative frequency. However, I'm just going to list some frequencies over here as well. So for frequencies, if we went up by 1, we could certainly do that graph, but we'll convert over here instead to relative frequency. So we already saw here that 1 as a frequency was equivalent to 0.04 or 4%. So instead of labeling it 1 as a relative frequency, and I'm going to do it in decimal here, 0.04. And that means that rather than going up by 1, we'll go up by relative frequency 0.04. So I'm just adding 0.04 to make my way up here and filling in my relative frequencies. If I could add correctly there, I messed up that one up, 0.28, 0.32. All right, so on my x-axis, we've got our axis break. So we want boundaries here. So we'll start that boundary at the 49.5. That was our initial boundary. And then we know that the width here was 10. So we had added 10. That will get me across the page. All right, and then, so my first group of students between 49.5 and 59.5, and notice here, I know we're labeling boundaries. That's how the graph is created, but we might, if we published it, might just say to people reading it that these are students between 50 and 59, right? These are my students between 60 and 69. All right, but the boundaries are actually used to create the graph. So if we go back up and look at the students in the 50s, that was 7 students, which was equivalent to 28%. So 7 students equivalent to 28% or 0.28. So it looks like our graph, we've done it correctly. So that first bar of the histogram would be at a frequency of 7 or a relative frequency of 28% or 0.28. And then I'm just shading it so you can see it a little bit better. And then my second group of students in the 60s, there were 8 of them, or equivalently 0.32 or 32%. So there's my next group of students. And the next group, we had 6 students or 0.24. And then my students, these would be in the 80s. There were 3 of them, 0.12. And then finally, my student in the 90s out here. So this was 90 to 99. There was just one of them, and that was equivalent to 0.04 as a relative frequency. All right. So just for completion here, I'm writing in my other limits at the bottom. All right, so my x-axis here represented grades, and that is called a relative frequency histogram if you present relative frequency, or again, we could have just done frequency, and that would be a frequency histogram. All right, so in terms of shape here, I'm not very happy about this, how this class is performing actually, because it's looking like low grades here, more low grades, and then it tends to taper off as I get to the higher grades. So in general, that shape, more of the data on that on the low end, and then it sort of tapers off as the grades get higher. So that shape is skewed. And the direction of the skew is the direction we taper off, or I like to think of it like a sliding board here, my little dude sliding down. So we'd go up the stairs and we'd slide to the right. So sliding to the right is skewed to the right. Okay, and there you have it, a relative frequency histogram.